Hello, Internet. I'm in my new place in Washington. Moved all the way from the state of Virginia here to Washington. Oh my gosh, never moved so far as an adult in my life. Actually, I guess even as a kid, we at least went halfway across the country before going the other half. I don't know. But anyway, yeah, big move. But what I really want to talk about, the reason I'm making a video is I've been inspired to talk about one of my favorite topics in programming, inheritance, in particular object-oriented programming. This comes up. So I don't know who's watching this video, and again, I don't have to worry about my audience because I'm not trying to monetize. I'm just having fun. So let me tell you a little bit about what inheritance is in programming. I think a really kind of classic example is, as you might say, let's say in your let's say game. I make a lot of games. Let's just say game. In your game, you have animals, and so you might say, okay, there's a type of thing called animal, and maybe it has some properties like heart rate. I don't know, some super basic things. And the reason why I want them to be super basic is because you might then from animals say, oh, we have like cat. Cat is a kind of animal. Or snake. Snake is a kind of animal. Or, what are the other things? It might be ant. Ant is a kind of animal. Do ants even have lungs? I think they circulate things differently. I don't know. Breathe through their skin. I don't know, right? So you have to be careful because animals don't necessarily on their own have many things. Maybe they have a position in your world, right? Somewhere that they can be. And maybe that's also a property of your animal. And it's called inheritance because when you say in code, hey, a cat is a kind of animal, then it says, okay, cats inherit all those properties from animal. They have their heart rate, and which assumes all animals have hearts. I don't know what jellyfish do. And this is kind of spoilers for where this conversation is going. And position in the world, right, in your game world, let's say X and Y coordinates if it's a 2D game. So, right, it just gets those properties for free because they're what's on animal. And as you evolve your game over time, you're like, well, now animals need a velocity as well, let's say. So you add it to animal, and voila, all of your animals, because they're all animals, just, specific types, they gain this property. In college, I feel like, so when I first learned, like really learning about it, there's a lot of emphasis on inheritance and object-oriented programming and how you do it, including things like, so here's an example, right? When you say here's an animal and then here's a cat and here's a snake, you can't say, well, here's a thing that inherits both cat and snake. And that's like a diamond shape you form, and it's called the diamond problem. And the reason you can't do that is because what if somewhere down the line you add a property to snake? I'm trying to think of what that would be. I don't know, number of scales, but you wouldn't add that to cat. But there's a better example out there. The problem is you could add things with the same name in both snake and cat, but maybe they're like mean different things or different types of data or something, and so you can't have one thing that inherits both because then there's an ambiguity. And I wish I could think of an example for, I don't know, maybe there's something about teeth being pointy or not or something, and you're like, well, this thing has that property and it behaves this way, but this thing has this other property but it behaves a different way. I don't know now what you mean when you have this weird fictitious combined animal that's a cat snake. Which one you're referring to and which one I should use. It gets confusing. Again, I wish I had a better example, but hopefully that makes sense. And it's called the diamond problem, again, because you've made this kind of diamond shape. And that problem manifests in that most programming languages say, okay, then you can't inherit from multiple things. That is not allowed in the program because it could create an ambiguity and we wouldn't know how to resolve it. So we just don't allow it. So you learn all these crazy details. And at least what happened for me, and I'm curious what happened for other people, but I think other people have had similar experiences, is there's so much emphasis on object-oriented and how you do it, how it works, how to use it, that it feels like this really important thing to use. Like they tell you how to use it, but at least in computer science, there's no like why would you choose this tool and why wouldn't you choose this tool. And the animal example is a useful one, like we were talking about, like because the idea of inheritance, it's very compelling. It feels like this great way to organize and structure very clearly these relationships, kind of like a tree of life, right? You might even imagine doing the tree of life, like we have animals and I don't know, chordata. What are all these phylums? Yeah, I don't even know. I'm not a biologist, but we talk about this as being this tree of life. And so it feels compelling in so many ways to organize things in that kind of way. You might even say, well, look, there's foods, and then there's desserts, and there's other things. But the problem is that you very often with those systems, they work really well in the beginning, and you're like, great, I've inherited all these useful properties, world position, heart rate, whatever. But then as you build the system out, you start to run into other problems where they're not really like related in that way. Like, the way they say in programming to think of it is it really should be an is a relationship, right? So like a cat is a animal. I think an example of something where you like a good, here's another example. A person contains an address, and so you would want an address property to be on a person. We also have homeless people, but it's a nullable property. But you wouldn't say that a person is a kind of address. So you wouldn't inherit from address to make a person. And I think that's a kind of example where it's like, oh, obviously you wouldn't do that because a person is not an address, whereas a cat is an animal. So that's what you're looking for in inheritance. But I think even that word, that is the English doesn't, and this shouldn't maybe be a surprise, English does not, it's not perfect. It's not as clear cut as we would like to think that it is. When you say something is a something else, it's like, well, what do you really mean? Because even, so think about back the Tree of Life example, what is a species? And we have in biology these things of like what counts as a species. Oh, if two creatures of different species, they can't mate and create offspring. It's like, oh, well, okay, they kind of can, and that's how come we have like, we got the donkey, horse, mule situation. But those are infertile, so that's what happens there. And you're like, oh, well, but actually there are these other kind of things that are different species. I think it's like there's a couple kinds of bears or something that are different species, but they can mate if they happen to ever interact in nature. They wouldn't because different climate. I think it's like polar bears and some like other, temperate bear or something. They can mate and create offspring, and the offspring can make babies, but they are different species for other reasons. So are they really different species? Right? The real world is very mixy and muddled, and saying, oh, well, it is a kind of X, X is a kind of Y, whatever, cat is a kind of animal. It's not as easy as that, basically. So I think I kind of, again, as I mentioned last week, I've been programming like, I don't know. And I hesitate to say this because just because I've been doing something for a long time doesn't mean I'm good at it. I mean, I think I'm pretty good, but there's always more to know, right? There are things I suck at, and that will always be true. I'll always be getting better at things, and new things will be coming out, and new ways of doing things, and everything else. But so anyway, I hesitate to say I'm good at programming. I'm doing it a long time, but yeah, there is some truth to to saying that. I have been doing it a while, and I know some things. I should hope so. Otherwise, I'm terrible at this. At life or something. But anyways, because of college, my experience was these things felt so important. I really was like all in on. It's like, yes, this inheritance tool is super good and super useful. Clearly, they taught us all about it. And again, I think the inheritance tool in programming is very extra sneaky because it seems to be really good at first. When you first start using it to categorize things, it feels like you're doing things very well. And so I was like, yeah, inheritance. There is this rule of thumb in programming, which they don't teach you in computer science. This is probably more. Now we have software engineering as a degree. That's probably I don't want to say a better degree. They're for different things. I now engineer software. So software engineering would have been the better thing for me, but that just didn't exist as a degree at the time, at least not at my college. I don't think in most colleges. But anyway, composition over inheritance, that is the rule of thumb. You should prefer composition. So the example before of a person contains an address, that's one of its properties along with name and everything else. You might have this address object that has city, state, street address 1 and 2, whatever, all those things. That is the general thing to prefer rather than inheritance. So if you ever don't know what to do, or you're just acting real quick and don't have time to think about it, the default should be composition. Put it in as a property. And so in the animal example, you could do this. So suppose you've decided that your animal thing, you're aware, you're thinking ahead. You're like, well, some animals, I don't even know that they have lungs or hearts or organs. We can't make maybe heart rate is even too much, but we do know that everything is going to have a position in the world. So maybe instead of making this animal class and having cat inherit animal, you should make a location thing and say, well, cat is going to get a location property. And if you need to be, yeah, let's not talk about interfaces, but interfaces could help you here if you needed to know more things at runtime. Blah, 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 blah. That's the default. The point is prefer composition over inheritance. And I was starting to hear that. I had been seeing everyone go nuts about inheritance, including myself, so I tried to make a game on my own, because then you can work faster, right? Where I was like, I'm going to double down on this inheritance thing, because I think inheritance is pretty good, and I think I can describe a lot of things, in this way. And that was great to do because I was totally wrong. and the weaknesses started to show. And again, at first making this game, and the game is Mysterious Space, by the way, you can go and play it. And one of the reasons I don't continue to work on it is some of the problems we're going to talk about. So I decided, I don't remember what I called kind of the basic game object, but it was probably something like game object, right? And it had a position. I don't know, maybe some other things. It would be interesting to open the code and take a look. And then from there, I had things like, well, here is a decorative object, or like a particle that is just flying around and then expires, to make like explosion effects or whatever. Here's also ships in general, things that are flying around. And then, here are player ships and enemy ships, because those act a little differently. From player ships, we have like these 6 different ships that players can be, or something, I forget, approximately 6. And then here's all these enemy ships, right? And those inherit from things. And also there's a boss thing that inherits enemy ship, and then from boss you have the different boss classes, right? So there's this like and then bullets are somewhere in here, and right, everything else that is in the game drawn somewhere was part of this huge tree. And again, at first this was working great, but then as you want to start changing things, it becomes very difficult. So one example is all ships should have, and part of the reason I wanted to do this with this game idea in particular was like, okay, I want enemies and players to be following the same rules, because I really like when games, you can tell when a game has been programmed this way, because it's like, you can just, anything an enemy can do, I can do, like, blue mages in a Final Fantasy game. The reason that you can do any spell is they've just said all spells are the same, and enemies use them and players use them, and it's okay because it's just all spells. They're all in the same category. We're not making special rules, so anyone can do it. Or, in theory, maybe you could possess an enemy ship and now you can control it. And it's okay because it's the same thing. There's actually a way better way to do that. Anyway, spoilers. Inheritance isn't good in general. So yes, the problems start to show when you start off that way. You're like, okay, great, everyone is going to have the weapons that they have equipped, and the enemies will shoot weapons. But then as the game goes on, you're like, well, isn't it interesting now? I have this new kind of player ship I want to make interesting that isn't going to have shields, I think was what I did. They only had armor, or vice versa, or other restrictions like that, where now you want to have like a funny exception, like, I don't know, the species that actually can mate with a creature from another species, right? There are these exceptions that are interesting in gameplay, maybe you want, because it's interesting for gameplay. And so then either you have to say, well, you've already got this whole system where everything just has all these things. It becomes very hard to change now because everything is related down these deep trees. So then you have to start coding in all these exclusions, special things like, well, you have to add checks, specific checks like, but if it's that kind of player ship, then don't let them, equip shields or whatever, right? It starts to get this messy, confusing thing. You've created a system that's difficult to change. Another rule of thumb in programming, something people say, is good code is easy to change. And inheritance creates code that is very difficult to change. The bigger the inheritance tree, the harder it becomes. There's also another thing in programming, a phrase that I love and I've only learned recently. It's called false sameness, the trap of false sameness. So two things look very similar, right? Animals and being a type, it's like, they're all animals. They're all going to behave roughly the same way. They're all player ships. They're all going to behave roughly the same way. Let's use inheritance. It's so often not the case. And I don't know how to properly describe too, because again, this is like kind of the muddiness of English, where we say something is a something else. It's like, I don't know, just because it sounds good in English, or even if it would make sense in the real world, what you're doing with your particular software, that might not be the case. I don't know if it's a totally different context, but it's a different enough context. And again, the things we might say in English and we all understand to be true in English, when you translate it to code, you're like, yeah, but not actually, right? This is like, we say that, but that's not really how it is when you get down to the functionality or something. So the concept of the trap of false sameness is it's one of those phrases that gets in my brain. Composition over inheritance. False sameness comes up a lot. I feel like in web APIs and DTOs and blah blah blah. It's a whole other topic. A pit of success. I love that's another phrase I love. Creating pits of success in your Microsoft is big on that with their language and their frameworks. They want to create pits of success. Love it. So yeah, anyway. So false sameness was a big one for me. And again, good code is easy to change is another interesting one. And anything can be taken to a crazy extreme. You could take any one of those principles that's good, and if you take it to an extreme, you're going to do something insane, right? Like if you want to say good code is easy to change, and you're really going to go ham on that, you would probably create something horrible. Really going ham on inheritance within mysterious space. There's probably a limited amount of inheritance that would have been suited much better and made the game more long-term maintainable. Again, it just became so hard to change things, to add things to the game, that I was like, okay, I'm ready to go on to another game now, right? Especially because it's not really my job to make games. I make games for fun, so there's not like a monetary incentive to keep doing a thing that has enough friction, it's not fun anymore, right? It's like, this code has become too much trouble, and I've got 1,000,003 game ideas in my brain at any given moment, so let's knock that down to 1,000,002. Oops, it's tomorrow, now there's 1,000,007, whatever. This I just keep generating game ideas, and again, doing it for fun, so if the code base becomes unpleasant, then I'll move on to something else. And people will do that for work too. They'll find new jobs, right? It's just harder. In that situation. But yeah, and I don't want to make projects that I want to abandon. People play the games and they're fun, and so I want to make code, even so for both fun projects and for work projects. I want to make games with good code so that I keep making the game, because I want I make these games to be played, and once people are playing, I want to disappoint everyone. And then for work too, right? I'm making code for work. I don't want to switch jobs. It's a pain in the ass, and you have to feel an ownership over this thing you've built. It sucks to right to have to switch jobs. So I wouldn't want to. And you're working with other people. I don't want to give other people shitty code, right? So. So anyway, what's the point? The point is, okay, so why did this all come up? Why this conversation? What made me think about this? A person I've been working with for I think 3 or 4 years, or we started working together that long ago. Now we have different jobs. But this was a big topic early on, is, again, I see so many people. It feels like maybe everyone just has to go through this in the same way I did, or many people do, of inheritance is great. Oh, never mind, it doesn't actually do everything I want. Oh, you know what? Actually, this is just more trouble than it's worth, and I kind of I forget. There's a programming language that when it launched, they were no inheritance. I forget. Go, Rust. I don't know. One of these new languages, they were no inheritance. And when I heard about that, I was like, I fucking respect that. That's incredible. Not monetizing, so I'll swear as much as I want. I thought that was incredible. They eventually did add it, and that makes sense to add, right? You can't just say never no inheritance. Inheritance is a useful tool. There are jobs for which it is the best tool. So you want it in the toolbox. But anyway, this person from this friend of mine, she is now at a different job working on this old code base. It's not that old, but it's an unfamiliar code base to the people working on it. They inherited this project from another team, and now this team is working on it, and they don't have a ton of experience in this particular language. And she's seeing people just go nuts with inheritance and do all these crazy things. And so she texted me this morning and was like, "Oh man, I'm really not liking inheritance recently." And the response I texted was I only wish I could have convinced you. The only thing I've learned from this experience is how do I convince people sooner than 3 years or something. I forget the words I used. It was more succinct than that. I almost want to pull up the text message, but anyway, it's yes, you believe me, and I wish you believed me 3 years ago, because it was an argument that we had at the job where we worked together, where I was like, please don't reach for inheritance so quickly. It really is not as helpful as you think. And it gets people in trouble so much more often than it helps them, I feel like. And again, other people agree. They made a programming language that didn't have inheritance at first. I really wish I remembered what it was. You can ask the internets, Google it or something, Chat GPT it, whatever you want to do, Claude. Yeah. So anyway, I don't know what's the point of this video. It's me rambling. I don't think I'm going to convince anyone of anything. At least for me, the best way to learn has always been to do the thing, right? I hear someone say, my boss is telling me composition over inheritance. I'm like, are you sure? Let me go ham on inheritance and prove how awesome it is, and then go, oh, it's not that awesome, right? It has these problems. This is why you don't want to go ham with it. Everyone still says go ham today, right? So anyway, play with this stuff yourself. I guess that's the only thing I can really say, right? You're never going to believe me because I just made a video, and you shouldn't. People will say everything every which way, and it depends on context. Maybe there are situations where you would reach for inheritance more often than not. I don't know what those situations are, but that could just be because most of my programming has been in web development, a tiny bit of like desktop stuff, but barely. I'm not going to really claim to have any expertise there. But I don't know. Maybe when you're doing, I don't know, that's something I've never done before. A field, an application of programming that I just haven't done. Maybe inheritance is just the tool you go for and grab. I don't know. So play around with it in the context that makes sense to you and see what you think. But I think computer science needs to stop teaching people inheritance so much because it's making them think it's better than it is. So anyway, that's the end of my silly ramble today. That's it. Thanks for watching if you watched. Bye.